welcome back in our sorting station. In the previous video we have seen how to control the different actuators in the runtime inspector. But what we want to achieve is to control those actuators like we would do the real controller. So we will give a binary input, value true or false, and depending on that value, the actuator will move to its desired position. So in that case, we will use signals that we have here in the electrical part. So I will create a signal. So in this case, it will be an output coming from the PLC to control the actuator. So in this case, for MCD, it will be an input for MCD, but this is an output for the PLC. This is important. We will see later why. So I will give my signal a name. Let's call it belt. Okay. I don't need a symbol table. And here I have my signal. So now what can I do with this signal? I can create an operation. Here in the operation, I will change the parameters of an actuator. So for the physics object, I will select my belt. And I see here the different parameters I can change. So in this case, we will say it is active. If, so I have condition here, I can add a condition object. I will take the belt signal. Okay. And I have the condition here. So if belt value is true, in our case, then the belt will be active. Okay. And I think, yes, we need a speed here. So now if I click on play, and I go in my runtime inspector, I will select our signal and the belt. So, yes. So I will deactivate it here. I go in my runtime inspector. So the value of the active is false, so our belt is not active. And if I set my belt signal to true, our belts become active and we see it's moving. Now if I get back to false, it doesn't stop moving. It's still active. Why? Because in our operation, that by the way we can find here, we say that if the belt signal value is true, then we activate it. But at no point we deactivate it. So for that we will need to create a second operation. Deactivate it. So I will select again my belt. I will take active is false if my signal is false. Okay. Okay. So now if I click on play, I can see here my belt signal value is false. So I set it true. Our belt is running. I set my signal as false. Our belt stopped. True is true. Running false. It's false. So it's deactivated. So we have here like a normal behavior we would have in the normal control from the PLC. We have a binary output that controls it on, off. Now there is also another way to control other than operation. It's called the expression block. So if we create an expression block, we can choose the input, the output, and give an expression to the output. So first we will apply this for the stopper, and first we will create a signal. Here we create the signal stopper, and this will be an output from the PLC, so it will be an input for MCD. So our signal is created, expression block, and I will define my input. So my input in this case will be the stopper signal. Okay, I use the value. I can rename it here in the expression. It's a stopper command. And the output will be the stopper position control. So I add an output. I will select my stopper position control. And here for the values I can act on, I see I have limits, but my position is not available because in the data type, in this case, I need to select a double data type, and now it takes my position. Okay, let's call it stopper position. Now in my expression, I will assign a formula to the stopper position. We can do math function or conditional. In this case, we will take the conditional with a simple if-then. So in this case, it would be if stopper command is true, then I will retract my stopper, then the position will be 0. Else, if it's not true, I will extend it, so my position will be 10. And I can give it a name. Okay. So my runtime behavior, I can find it here. And now if I click on play and I run the simulation, take my stopper signal, and I will observe my stopper. So when the value is false and it's outside, which is correct. If I set it true, it goes in, it retracts. If I set it false, it extends, true, it retracts. So the expression blocks are here another way to change the parameters of our actuators. And now we would be able to simulate already a bit the behavior of the station. So I click, for example, I will, so this one we don't need, and here we have the source of the black workpiece. Okay, I have my workpiece. I can start my belt just by activating the signal. With the other signal for stopper, I can retract it and re-extend it. I can stop my belt. I can restart it. And we are here on the good way to be able to start to control the station with the PLC. And the third way to control our actuator would be a runtime expression. It will be a bit like an expression block. We will see it. First, we will define our signal. We will do it for the first separator. Okay. And here we will select the runtime expression. We will select our parameter to assign. So it will be the position control of the separator 1. And we will select the position. Then we have the input parameter. We will take our signal we just created, the value, we add the parameter. Now we need to give it a name, separator 1, okay. And for the formula, it's similar to the expression block, so we'll insert condition. Simple if then in our case is enough. So if separator 1 is true, then we will go to the angle of 50 degrees, and if false, we will go to 0 degrees. Okay, and my runtime expression is created here. So now if I click on play, the simulation, I go in my run. I select my separator 1 for my runtime expression, my signal is here, and for the moment the value is true. If I change false, if I change it to true and back to false, we see that our actuator is moving according to our binary signal. Okay, so that's it for this video and how to control the actuators. In the next video, we'll see how we can simulate the input signals, for example, coming from sensors.